Hi and welcome back. Coding moving average crossovers. We will now move ahead with some simple technical studies on price data. A moving average is one of the simplest studies. This lecture paves the way to developing our first Hello World strategy using moving average crossovers. We will use two moving averages, a fast moving average and a slow moving average, to analyze the data and generate buy and sell decisions. A moving average is referred to as a simple moving average or also as a rolling mean. It is nothing but the average price over the last n days. For example, say we want to find the value of 20-day moving average. The 20-day moving average will be the average of the prices of today and up to the past 20 days. The moving average value of yesterday would include the price from yesterday up to the last 20 days. To code the moving averages, we use the different AlgoJi classes and methods. All classes and methods of AlgoJi are well documented. You can rely on this documentation as a good reference guide. To code trading strategies, you will need to learn about objects, classes, constructors, namespaces, mixins, encapsulations, and other object-oriented concepts. But if you are not familiar with them, do not worry. Some of these concepts I will explain step by step with my codes. Some concepts you can learn by reading the programming references, and some concepts you will pick up gradually while you code yourself. Great, now let us go to the code files. I have given you the code files in .txt format. You can simply copy the code from the .txt files to the py files in your PyCharm project. To code for moving averages, we start by importing the essential packages we need for building a strategy. The first package, strategy, is a base class in AlgoJi required for almost everything you need to do about strategies. Then we import the moving average class. We need the plotter class to plot the averages. We need the CSV feed class to read from our CSV data files. Strategy signals are generated or interval by interval or bar by bar. To create bars, we need the bar class. Next, we define the MA strategy class, which will serve as a template to plot the averages. It is initialized with data feed, instrument, and the two moving average periods, that is n fast and n slow. If you are already familiar with object-oriented programming but coding in Python for the first time, you may find the keyword super and self a little weird. Let me explain you a bit on them. For example, consider this class definition, which is written in Ruby. You define a class, you define a function in the class, and you define the attribute using @of. In Python, you need to essentially pass the self parameter to bind the object's data to the class. In the older way, when you define myClass.my function, it is actually an instance method. In Python, you use the init constructor, and when you define instance.myfunc, it is a class method which takes instance as the first parameter. By passing the object's name into the self parameter, it means that if 100 objects are instantiated from the one class, they can all keep track of their own data and methods. Consider another example. Say we define a human class with two parameters, gender and age. Init is the constructor, self.gender is an attribute, self.age is also an attribute. To create objects, we use these two lines of code. Amit equal to human of male and 25. Ria equal to human female, 22. Here Amit is a variable containing object from the human class. Ria is also a variable containing object from the human class. When we define a child class inherited from the human class, it is useful to use the super keyword with the constructor in it. The benefit of super is in single inheritance are minimal, that you don't have to hardcode the name of the base class into every method that uses its parent's method. However, it is almost impossible to use multiple inheritance without super. It includes common idioms like mixins, interfaces, abstract classes, etc. If you want to extend someone else's code, that is what we are doing using the AlgoJi package. It will not work properly without the super keyword. So in this way, we define the attributes position, instrument, fast SMA and slow SMA. We define the two functions getFastSMA and getSlowSMA to fetch their values. A moving average calculated over a shorter number of intervals is called a fast moving average, and a moving average calculated over a larger number of intervals is called a slow moving average. This is basically because the fast moving average moves faster to the recent price changes because it contains lesser number of intervals used to calculate the rolling mean. OnBars is a mandatory function need to be defined when you are using the strategy class. It is used to define the buy and sell rules. Right now we do not have much use with the OnBars function. Next, we define the MAplot function with n fast and n slow, that is the periods for the fast moving average and the slow moving average. After defining the necessary class template, this is the function which will actually do our job. We define the instrument, which right now is only the Nifty. We create the feed object and add bars to the data feed by reading the data from the CSV file. Next, we create an instance MA_plot from our strategy class previously defined. The strategy plotter is used in AlgoTrade to plot all graphs. Plot all instruments equal to true means it will plot the graph for all instruments in a list. We do not have buy and sell right now, so we have kept it as false. Also, we have not defined any portfolio, so there is nothing to plot in the portfolio either. Next, we plot the fast moving average using the getFastSMA function we defined earlier. To plot the slow moving average, we use the getSlowSMA function. Everything is done. To plot the graphs, we simply call this function MAplot with the two parameters of the moving averages 15 and 30. To run this code for the first time, right click and select the proper file name. To study it, we will now maximize it. I can zoom the graph using the right mouse click button. The purple line is the Nifty prices, the green line is the fast moving average, and the blue line is the slow moving average. When the prices turn up, the green line turns up faster than the blue line. That is because the green line or the fast moving average is calculated using a smaller number of intervals. So it reflects the recent changes in prices at a faster rate. You can think of this moving averages as the market trend. The fast moving average shows the short-term market trend and the slow moving average shows the longer-term market trend. If you want to make money from the most recent market trend, you buy when the fast moving average crosses above the slow moving average. Let me zoom out the chart once again. As per this trading premise, a buy signal was generated in early 2016. The prices kept rising up to October 2016 until when the fast moving average crossed below the slow moving average, indicating that the trend is now downwards. It crossed above again in early 2017, and then the prices resumed the uptrend or upwards trend. Excellent. We will now discuss another study called Moving Average Convergent Divergence, or the MACD. Thank you for attentively listening to this lecture. Let us now move forward to other technical studies.